This topic is called solving a multi-step equation given in fractional form. That just means that there's a fraction in our equation, or maybe on one side of our equation. When I see something like this, I like to think about two fractions that are equal to each other. So this would be -6, and I'm going to put that over 1 because this might be helpful. When we have two fractions equal to each other, that is called a proportion. And in a proportion, cross multiples are equal to cross products are equal to each other. So if you multiply across, like the numerator on the left with the denominator on the right, and the denominator on the left with the numerator on the right, and you multiply these two, it will be equal to the multiple of these two. So once we do that, we can solve for our variable. P.S. Please subscribe to my channel and like any videos that are helpful to you. So we're going to multiply -6 by -3, and 1 times 5x minus 27 is just equal to 5x minus 27. So we're going to do -6 times -3 is a positive 18. Now we're at the point where we can solve for our variable x. Sometimes drawing railroad tracks kind of by the equal sign will help us kind of separate where the variable is and where it's not. So the variable is the term that's 5x. So because there's a minus 27, we're going to add 27. We always want to undo adding and subtracting first. So because there was a subtracting here, we want to undo it by adding. So 18 plus 27 is, let's see, 8 plus 7 is 15. Carry the 1, 2, 4, 45. And this is just going to be 5x because we got rid of that 27. Then because we want 1x, we're going to divide both sides by 5. That will give us 1x equals 45 divided by 5 is 9. Sometimes solving an equation with the variable on the right side of the equal sign can be a little disconcerting because we're not used to that. It's okay if you switch. So that would be kind of at this point. If you wanted to put the 18 over here and the 5x minus 27 on the other side, that's okay. You could totally do that if it's more comfortable. In fact, if it were more comfortable for me, that's exactly what I would do. Okay, let's do another problem. So we're going to cross multiply again in this case. Or we can start seeing a pattern. So after we do this one, we'll do the third one by the pattern that we notice. So our cross multiples, we have 4 times 6 has to equal 1 times x plus 38. 4 times 6 is 24. 1 times that is just x plus 38. Now solving for x, we can subtract 38 from both sides. I'm going to put the 38 up here because we have to do a subtraction problem. Because 38 was negative and it's farther away from 0 on the number line than 24 is, the answer has to be negative. So when they have opposite signs and you're adding, it takes the answer, you subtract the two numbers without the sign, so 38 minus 24, and the answer will take on the sign of the number that has the greatest absolute value. That means the number that is farthest away from 0 on the number line when you compare the two numbers that you're subtracting. So notice here that we just multiplied the denominator 6 by 4, and we actually multiplied x plus 38 over 6 by 6 to get x plus 38. So that's kind of a pattern that we're doing. So let's follow that pattern on the next problem, on the last problem we're going to do. So we're going to just say that our 3x minus 14 is equal to 2 times -4 or -8. Now you can set it up like we did in the first two examples so that you can see it will turn out this way. If you need to, that's okay. Take the time to do that so you can understand a little bit better. Because we have a subtracting 14 from our 3x term, we need to add 14 to -x. And that's going to be 6. So this will be a positive 6 because the 14 is positive and it's has a greater absolute value than -8. Then we're going to divide by 3 and x has to equal 2. And that will be the end of our lesson.